Okay, for number 1, we are simplifying this fraction. It's one term divided by one term. Number 2 is two terms divided by one term. Okay, so that's the difference in the problems. So for this first one, we want to look at the number parts first, the 14 over 21. And what I like to do sometimes is just give myself a fraction bar, because I'm going to do each of those things individually. If I need something on top or bottom, I already have the space there for it. So looking at 14 over 21, what can I divide out of both of those numbers? 7. Okay. So I divide 7 out of the top and 7 out of the bottom. 14 divided by 7 is 2. 21 divided by 7 is 3 on the bottom. Okay. So I've got 2/3 to get me started. For the x's, where are the most x's, top or bottom? Bottom. So I put my base on the bottom. And how many are left over once I cancel out stuff? 4. Yeah, and y to the 6 on top. Okay, there's more y's on top, so y is going to go up there, and then you can cancel 6 out, and that leaves 6 left over. All right, so who got that one? Now for problem 2, the way that's different is now it's two things divided by one thing. And that video we watched yesterday said to rewrite it as a fraction, like this, to get started. To the y's. And then break it up into two different parts. It said split it up. And what's really going on here is it's kind of like distributive property. This term gets divided by negative 3xy, and this term gets divided by negative 3xy. So we've got 18x cubed y over negative 3xy minus comes from the problem 36xy squared over negative 3xy. So we've got this. So now what we have is problems just like number 1. We have 2 of them with a minus between. So it's the same skill. So in this first one, I'm going to give myself a fraction bar. 18 and negative 3. 18 is bigger than 3, so my answer is going to be on top. What is 18 divided by negative 3? So negative 6. X's, there's more on top. It's going to be squared because there's 2 left. And what's up with y over y's? They cancel. It doesn't leave me 0. It leaves me just 1. A 1 there, right? Because y divided by y is 1. And I don't have to write the times 1, right? It's just negative 6. I mean, technically what's going on is I have a times 1 there. It's just negative 6x squared. So then we do minus the next term. Set up my fraction bar. 36 divided by negative 3. The 36 is bigger than 3, so my answer is going to go on top. What is 36 divided by negative 3? Negative 12. X over x. Right. So it's going to be just y, because x over x is just 1. And then y squared over y, there's more y's on top. When one y cancels, it leaves me with 1 left over. Now this answer, this way I have is kind of awkward, so I'm going to clean it up a little bit. The first thing I'm going to do is minus a negative makes plus plus. So I have negative 6x squared plus 12y. Who got that? Who got it except for the plus? Okay, because that was tricky. I don't think a lot of people.
I thought my answer was completely wrong because the y. I should play it again. I just thought it was wrong.
Okay. What we're doing today is long division of polynomials, and here's why we even have this thing. Because so if I was looking at the warm-up, for example, I have in number 1, I have one term divided by one term. Okay. In number 2, I have two terms divided by one term. So it's one term here that I'm dividing by, and only one term here. Long division is for when you're dividing by something that has 2 or more terms. Okay. So like let's say instead of, we have, some problem like this thing right here, this is what we did yesterday, okay? But once you take that x to the 4th on the bottom and add or subtract something to it, then this method that we have no longer works. So we need a different method, and that method is called long division. You've done this before. You might have repressed it. The good news about long division is it's just repetition. So once you remember what to do, you just have to do it repeatedly. The bad news is the problems can get really long, and so if you make like one tiny error in the middle, it messes up the whole thing. Well, we're going to go over that too. So here's what we got. We're going to do two kinds of long division today. One with remainders, one with no remainder, and then one with a remainder, and see how to do that. But what we're going to do first is just review basic long division, because the process, a lot of it's really similar to long division with just numbers. So in that box on the top of your notes that says important stuff, oh, it sure does say important. I didn't even notice that. Okay. So we got important stuff up here. It's kind of like vocabulary, because you might hear me use those words. I'm not going to test you on those words or have you like fill in the blank or matching or anything, but you need to remember what they are in case you hear me say them, because we don't use those words very often. But it's faster than saying like the number outside the division bar or something like that, right? So real quick, as a reminder of these words, and I'm going to rewrite this left to right. 875 divided by 25 equals 35. Okay, this is the way we normally see the problem. This is the way we work out the problem. So that's the way we write it. That's the way we work it out. 875 is the dividend. Whatever you're dividing by, like the 25, that's called the divisor. And then your answer part, the 35, is called the quotient. So you might hear me say those things. And we're going to start by doing a standard long division with just integers. So 120 divided by 5. And I'm about to go over this process. Please understand, I don't actually care what 120 divided by 5 is. That's not the goal. The goal is to go over the process so we can see how it's similar when we finally do it with the x's. So that's the point of doing the 120 divided by 5. Okay, so here's what we do. Here's what we got. When you start doing long division, you would say, okay, 5 goes into 1, or 5 goes into 1 how many times? And you'd be like, none. So then you move to the next digit. 5 goes into 12 how many times? 2. So you write a 2. And then what do you do with that 2? What do we do with that? What's next? Yeah, how'd you get 10? Where'd that even before? So we're going to take this 2 times 5. And it gets brought down here. Yeah, and then we subtract it. Okay? So I'm going to do a minus there. And so 12 minus 10 is 2. And then you bring the 0 down. Right? Okay, you bring down the next term. And at this step right here, everything now just repeats until you can't do it anymore. So we start all over again. We say 5 times what gives me 20? 4. And I take that 4 times the 5, bring it down, and subtract. And in this particular case, I get a remainder of 0. What's my answer? 24. Okay, whatever's up here on top of the division house. There's actually a math word for that division bar thing too, but I don't remember what it is. Okay, so now keep all that in mind as we go over the long division for the polynomials, all right? We're going to start by rewriting the problem. Okay, we need the little division house thing. Which of those things goes under? The first, the x squared stuff, or the x plus 5 stuff? The x squared stuff. So x squared plus 9x plus 20. And then what goes on the outside? X plus 5. Right? So in the regular long division, I started with the 5 and the 1, right? That's with the first terms. I was like, 5 goes into 1 how many times? I was like, none, and then I went to 12. Here's how that looks over here. You find the leading terms. The leading term on the outside is just the x, and the leading term on the inside is x squared. Leading just means the first thing that's written there. And so on the numbers, I said, okay, 5 times what gives me 12? In the polynomials, I'm going to ask you x times what gives me x squared? Yes. Okay, so the question is, x times what gives you x squared? Yeah. So over here, I put the 2 on top. But remember, when I put 2 on top here, I lined it up over that 2 on purpose, right? Over here, so my question here is x. My answer to that question is x. So I'm going to line that x up over this x. All right? You're going to line up like terms. So x times what gives me x squared? X. And then I put it over that 9x. So then the very next thing we did over there was we took that 2 times the 5. What does that look like over here? It looks like take the x times the x plus 5, that entire thing. So x times x is x squared, and x times 5 is plus 5x. Okay, so the next step was I did the x times the x plus 5, and now I'm going to subtract that. But how many things are there to subtract? 2. They both need to be subtracted. Really what we're going to do is just change both of their signs, because that's the same thing as subtraction. So this becomes a negative, and this becomes a negative. So those first 2 terms cancel out, which is exactly what we're trying to do. We're trying to get x squared and x squared to cancel. Those are gone. And now I have 9x minus 5x is 4x. What do you think I'm going to do next? Bring down the 20, right? And the numbers, the next thing I did was brought down the 0. Here, the next thing I'm going to do is bring down the 20. And so bring down the next term. And then you repeat everything until you can't repeat anymore. So I start by now looking at the first term here. X times what gives me 4x? 4. So I line that up over the 20, because those are like terms. I do 4 times the x plus 5 and bring it down here. Yep, 4x plus 20. And what am I doing with those things? Subtracting. Which ones do I subtract? Both. That's right. I change the sign on both of them. And what's my remainder? That's gone. That's gone. 0. What's my answer? Good. X plus 4. I want you to try that next problem and see what you come up with. And it's okay if you don't get it. It's okay if you need help. Okay, so setting up this problem, what goes underneath the bar? What goes inside? 2m². Okay. And then m minus 3 on the outside. So you're looking at your leading terms, m and 2m squared, and you're saying, okay, m times what gives me 2m squared? Or m goes into 2m squared how many times? 2m. And you are going to line that up over the 2m. Now here, let me show you like an incorrect thing that I've seen a lot today, but I'm also going to tell you about how you could fix it if you do that. I saw a lot of people today, they just will write 2 there. Because they know that they're trying to get 2, so they write 2. But you can check yourself on that, right? Because remember, the next step is to take that and multiply it by both of these things. And, yeah, and it has to equal that first thing. So if you were to do that, you'd say, okay, that's 2m. But then you would think, oh, wait, I don't want a 2m there. I need a 2m squared. And so all you have to do is go back to that 2 you wrote and add in an m. And that would fix it for you. Okay, so just check yourself as you're going. So then 2m times that m minus 3 is 2m squared. And then 2m times negative 3 is negative 6m. And we want to subtract both of those things. Okay, so subtracting is the same as changing the sign. So this is a minus, and this is a plus now. So those first terms cancel. And then I have m plus 6m is 7. M. Now, what do I do next? Bring down the negative 20. And everything starts all over. So I'm looking at the first term in the divisor and the first term here, and I'm saying m times what is 7m? Right? Positive 7. So I take that 7 times the divisor, the m minus 3, I bring it down. And that's 7m minus 21. And I am subtracting both of those off, which means changing their signs. Right, and I get a remainder of 0 because they both cancel out. And what's my final answer? 2m plus 7. Yeah, 2m plus 7. Okay. So these two problems were for no remainder. So we're going to do another problem. It's going to have a remainder that's only slightly different. Okay, the repetition is good. Yes. Does anybody need this up anymore? All right, so real quickly, and I'm going to go through this faster. But I do want to just jog your memory about what we do with regular numbers when they have remainders. So I have 119 divided by 5. 5 goes into 11 twice. I subtract off the 10. 19. 5 times 3. Okay, and then I have a remainder of 4. The way we can write this lots of different ways. We can write 23 remainder 4. We can write it as a decimal. But for our purposes today, I want you to know that we're going to use the mixed form, 23 and 4/5. Okay, the 4 is your remainder, and the 5 is your divisor. But one other thing I want to bring to your attention is that really what's going on here with 23 and 4/5 is that there's an addition between there, and we're going to use that concept when we write our answer over there for the polynomial. Okay, yeah, there's a plus between here. So keep those things in mind when we get to this problem. This problem is longer than the last one, so that you can have practice. But there is also one extra weird thing. Not that it's extra weird, it's just an extra thing that's kind of weird. Which exponent is missing in the original problem? X cubed, right? Yeah. So you see it goes from x to the 4th and skips to x squared. There's no x cubed term. How we're going to deal with that is we're going to put something in there to hold the place. So there's no x cubed. What number do we use when there's none of something? 0. So what we're going to do is use 0x cubed as a placeholder. And we're going to put it right there between x to the 4th and x to the 2. So I've got x plus 2 on the outside. And on the inside, I have x to 4 plus 0x cubed minus x squared plus 5x minus 6. Oh, I already wanted to just take a nap. Here we go. Here we go. We start with the first terms. We've got x here and x to the 4th. X times what gives me x to the 4th? X cubed. And where am I going to line that up over here? On top of the x cubed. So I do x cubed times this. What am I doing x cubed times which of those? Both. So x cubed times the x is x to the 4th. X cubed times 2x cubed. First one, what am I going to do with those things? What's my next step? I got to subtract them, right? Okay. So I'm going to change the sign on both of them. The x4's cancel out. And now I have 0x cubed minus 2x cubed is negative 2x cubed. And then bring down the next term. Wash, rinse, repeat. We have to do this all over again. Now I have this leading term from the divisor is x. And this leading term down here in my problem, x times what would give me negative 2x cubed? Right. Good. Negative 2x squared. Okay. So I take the negative 2x squared times the divisor and bring it down. So negative 2x squared times x is negative 2x cubed. Negative 2x squared times 2, negative 4x squared. Change the signs. Plus, plus. The x cubes drop off. Then I do negative x squared plus 4x squared is 3x squared. And bring down the 5x. Oh my goodness. Okay. Now we have, this is my leading term. 3x, right? X times 3x gives me 3x squared. Multiply by the divisor, bring it down. So 3x times this x is 3x squared. 3x times this 2, 6x. Change the signs. Negative 1x. Okay. So the x squareds cancel. I have negative x. Bring down the negative 6. Now here's sometimes can be confusing for students. X times what would give me a negative x? X times what would give me a negative x there? Negative 1, right? Negative 1. So we write just negative 1 up here. And then do all of that stuff one last time. So negative 1 times x plus 2. So negative 1 times x is negative x. Negative 1 times 2 is negative 2. Change the signs because you're subtracting. Negative 4. So we didn't die yet. So we still have one more problem. So yeah, so when we go to write it, so we have this remainder. So when we write it in this form, the 23 plus 4/5, what up there is in the place of the 23?
The whole thing.
Everything on top, right? X cubed, blah, 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 blah. So we write that, we start by writing that down. X cubed. And then we do the plus. The remainder, yeah, negative 4. You could do minus here. You could do plus and negative as well. So the remainder is negative 4 over the divisor. What's the divisor? X plus 2. Very good. It's whatever we divided by. Oh my goodness. So one reason, I know it seems like obnoxious to do such a long problem, but the repetition is good for you because that's all this really is repeatedly doing the same thing. So repetition is good. I want you to do that next problem for a daily grade. I want you to do it by yourself. I want you to turn it for daily grade. I'll be grading it, but I don't want you to freak out, and here's why. And I don't want you helping each other for mainly because I want to see what you understand or don't understand all by yourself. And I don't want you to freak out because if you're honestly trying it, you're not going to get lower than a 90. So here's how I'm going to grade it. It's 100 if you did everything perfect. It's a 95 if you did the steps okay, but you got the answer wrong just because you're math or a negative or whatever. That's a 95. And it's a 90 if you really tried. I can tell that you really tried, but you were struggling and you just didn't get it. That's a 90. The only way you're going to get less than a 90 is if you like write IDK or you draw me some flowers or whatever people give me when they don't know what to do. Okay, so if I don't think you really tried, I'll have to come up with some other grade. But if you really just give it your best, make sure your name is on it, turn it in, you're not going to get less than a 90. Okay, I'm doing that so one, you're relaxed and calm and just doing your best. And yes, you may listen to music while you do it.